We are live.
Hi, and good evening, everyone, at the Andhra Pradesh MedTech Zone. A warm welcome and a good evening to everyone joining in. We are truly grateful that each of you could join us for our fourth conversation in the TECHRx series, Accelerating MedTech Innovation, where we bring the four MedTech innovations from across the world. TechRx is a collaboration between Inc. and Andhra Pradesh MedTech Zone, along with METI, KIHT. Inc. has had a decade long history of being a flag bearer, conversation starter, and accelerating the journeys of game changers from across the world. And we've collaborated with AMTZ that focuses on progressive initiatives of being a center of innovation in the space of technology and medicine. And the purpose of the series is to create a bridge between the scientific and the social segments of the society. Today's session is going to be a 60-minute session with the last 20 minutes open for a live Q&A. We also have audience watching us on YouTube, so I would request you to drop in your questions, and people watching us from the auditorium, I would request you to just raise your hands, and we have, you can just come forward and, have your questions, share your questions with us. Today's session will focus on robotics, healthcare, and innovation, and we have a very special guest, Dr. Sudhir Srivastava. He's the founder, chairman, and CEO of SS Innovations and Group Companies. And he, along with 10 additional physicians, founded the Alliance Hospital Limited, a center of excellence in the treatment of cardiovascular disease in Odessa, Texas, in July 2003, and served as its chairman for 4 years. While there, he performed the world's first single vessel beating TCAB in the United States. He also proceeded to perform two world's first double and triple vessel TCAB on a beating heart, and is the only person in the world to have performed a quadruple vessel beating heart TCAP while at the University of Chicago. Dr. Srivastava is also an active member of the Society AATS, the International Society for Minimally Invasive Cardiothoracic Surgery, and is the founder of the Robotic Revascularization Society. With that, I would like to call upon Lakshmi Pratury, the founder and CEO of Inc., who will be moderating our conversation for today. I would request Lakshmi to turn on a camera. Lakshmi? The stage is yours.
Hi, everyone. This is a very exciting partnership for us because one of the things I love is science. Ever since, Carl Sagan's pale blue dot conversation, in some ways, we are all insignificant. I mean, the galaxy with Earth or without Earth is the same. But if we can make an impact, we can keep this Earth be as great as it is to be a beating heart of the galaxy. But if we mess it up, we'll disappear, but Earth will still go on. So the idea is that for time immemorial, science and technology have come together with human consciousness, with each of us moving forward. We've used science and technology in ways we didn't even know. And when science and society work hand in hand, is when the true innovation happens. Carl Sagan also said that we live in a society exquisitely dependent on science and technology, and yet have clearly arranged things so that almost no one understands science and technology. So we've made it so much about a few scientists and a few technologists understanding it, not as much as our children, our youth, and all of us, no matter which discipline we are in. We have an opportunity to admire and administer science and technology in our day to day lives if we understand the essence of it. So, the purpose of this series is to bring the most complicated thought and how can we have a conversation about it so it gets into our consciousness in a very deep way, giving us the confidence to create an innovative society in the best possible way. And that's the purpose of the Tech RX series. We've been featuring the most amazing scientific minds on this and discussing about how does it apply to our day-to-day life. I'm Lakshmi Pratury. I'm the CEO of Inc. And I'm delighted to be curating this session, to be in conversation with Dr. Srivastava following his talk. So today, I really want to start with thanking AMTZ for its vision and Dr. Sharma for his enthusiasm to create this series. And AMTZ, is a star in the Andhra Pradesh government ecosystem with the primary vision of enabling startups through research and incubation facilities. I mean, what a novel concept of bringing startups and science together in the most innovative way possible. So, with that, we'll launch the TechRx series with a video uh, from AMTZ, followed by talk by Dr. Srivastava. Thank you. I'll be back after Dr. Srivastava's talk. Rohan, can you please play the video?
Dr. Srivastava, may I request you to turn on your video and audio, and you may also share your screen. Thank you.
Can you put it on play, please?
Sorry, doctor. May I request
Yes.
you to repeat yourself?
Yeah. So first of all, I want to really take this opportunity to thank Lakshmi and Vipasha and all the names that you see on the slide here, MTZ, TechRx, Inc., and so on. And really delighted to be part of this session today. And I'm going to talk about very briefly, in fact, because a highly technical subject, so mainly give an overview of the robotics in medicine. And then we will get into more conversation style explanations or question answers. So with that, if we look at the evolution, the slide is not moving. Okay. If you look at the evolution of surgery, and in fact, India takes a tremendous pride. Sushruta, our ancient surgeon, they started talking about surgery way back and started with open techniques. And then gradually they became less invasive and finally endoscopic. And robotics came into existence in early 90s. And what I see based on the evolution that I have seen and my own participation, that I think as more and more systems become available, the robotics will be the future of surgery. if you let's just catch up a little bit on how it all started. Back in the 1980s, NASA and Defense Department in the United States, they started funding Stanford Research Institute in California. And the idea was at that time the space missions were going on. And at times there are various wars and so on. So they started to look into how we can treat conditions that require surgery from long distance. And they spent tens of millions of dollars at that time. And one of the consideration was, even if somebody got an appendix problem while in space, they have to literally scrap the mission, waste hundreds of millions of dollars, and there was no way to manage these things long distance. And they developed the concepts initially in the research time frames, but unfortunately the technology and the bandwidth that was required, they were not available. So essentially they basically shelved the research. And in the 90s, a couple of companies came, Computer Motion and Intuitive Surgical. And Intuitive Surgical particularly licensed the intellectual property from Stanford Research Institute, and they launched a company. And Computer Motion was, in fact, one of the first ones to come up with a system that was used in surgery. Since then, over 9 million robotic surgeries have been performed globally. And essentially, the healthcare community, hospitals, as well as the physicians and patients have accepted it. If you look at the global scene, there are almost 300 million procedures get done every year. And each year we add roughly 5%. And of those, almost 65 million can be done less invasively. But if you look at the robotic scene, that only about 1 million procedures were done in 2018, and just over 1 million were done, in fact, last year. So it's a very small volume compared to what really the need may be. And so let's look at why there is need for robotic surgery. So robotic surgery can be done through literally tiny fingertip size incisions, what we call ports. And the various attributes of technology, including high definition magnified view up to almost 10 times. There are human wrist-like instruments which behave almost duplicate the human wrist. The tremors are filtered, and all of these things translate into very precise operations. Because of the technology and the wristed instruments and this high definition view, one can perform complex surgical procedures that normally cannot be done laparoscopically. These things translate into less trauma and much less complications, and finally, much shorter hospital stays, as well as very fast functional recovery. A lot of patients can go home in few days. In fact, in my own practice, after bypass surgery, almost 20% of the patients went home the next day. And what it does as far as the system is concerned, so in hospital, social, economic, there's a very positive impact. There's a very positive impact on emotional and entire healthcare system, because ultimately, although there is a front loading of the technology cost, but ultimately it will translate into a very different business and financial model for the healthcare system as these things become more and more available. When we look at the types of robotic system at this present time, there are these multi-arm, multi-port systems. There are multi-arm single-port systems, flexible, endoscopic, and then there are single-arm systems for some specific applications like orthopedics and certain neurosurgical procedures and spine procedures. What I see in future, I think there will be specialty-specific robotic systems. And further, we will develop procedure-specific robots. And right now, there is already existence of microbots. And these are little guys that one can drop in the body cavities or in the stomach. They will join themselves and carry out the procedures remotely. And finally, I think the nanobots, they are in the works. There is a lot of research going on in the field of nanotechnologies and various kinds of drug deliveries and so on. And at a micro level, at a nano level, the whole field of medicine is going to change as we move forward. So let's look at the current landscape of robotic surgery. it is very uneven. Even the rich economies like United States and other countries, essentially, even within those countries, there is uneven penetration. And the robotic surgery has become literally country and economic centric. And if you take the US, Europe, and Japan, almost 93% of the installed robotic systems are in these areas. So when we look at the rest of the world, over 6 billion people, there's only 7% penetration. When we looked at India and China in our region here, for more than 1/3 of the world population, we have less than 3% penetration. And when we looked at the reasons for it, it's a huge cost, capital cost per procedure cost and various maintenance contracts. And on top of that, there is a steep learning curve. So a combination of a steep learning curve as well as a very high cost, these procedures are not performed as much as they could be. So when we look at the scene in India, only 80 robotic systems are there. Almost all cases are non-cardiac, and that means you cannot do heart surgery with these. The annual volumes are only 10 to 12,000 per year. And the current robotic system sells in India, which is the most common system today and dominates the world, almost 18 to 20 crores. And procedures are expensive. On average, one can add almost 2 to 4 or 5 lakhs on top of the regular surgical procedure. And then we do not have organized teaching and training programs. So all of this translates, unfortunately, into less use of this wonderful technology and technique that offers so many benefits to the patients. So when we look at, and my personal philosophical approach to this was, disease does not discriminate against any region, race, age, and economic status of the people. And if innovation and technologies are not cost effective, they will not benefit most. And these technologies and techniques should have a global reach, not for just rich economies. And so my personal mission and vision became that we must change the direction of surgery with advances in technologies. And so we got a group together and got into the development. And the vision was to create a technologically advanced system that will leapfrog the existing technologies and systems. But the goal was to make it cost effective to benefit many, many more patients around the world. So with that, we formed a company, SS Innovations, and and I'm going to just very briefly cover this thing. So this various components of our robotic system. So robotic system mainly is a combination of components whereby, if you can imagine, we make large incisions in patients to be able to see. We can put our hands in and assistants can assist us. And this is where we make these large incisions. So we need eyes and hands to be able to perform these tasks. So with the robotic surgery, which is an endoscopic procedure, 3D endoscopic camera is inserted into the body cavities. Then the robotic arms carrying instruments act as extension of the surgeon's arms. And there is a vision card which displays the 3D beautiful magnified view. And I think as surgeons, we know better the vision, better the magnification, we can be more precise. And surgeon sits on a surgeon console that you see on the left side. And literally it is what we call a teleoperation. I think sometimes the word robot is a misnomer in my opinion. It is a teleoperation through computer assistance. That means surgeon looking at the 3D monitor with the hand controls and foot paddles. As I move my hands, my motions are accurately transferred through a very sophisticated software system that finally controls the robotic arms and for me to be able to carry out these tasks in a very, very precise way. So the surgical system today has applications in all of these listed fields in urology, gynecology, general surgery, thoracic surgery, cardiac surgery, and head and neck surgery. And these are just little magnified views of our system that I just described, and these components are listed there. And one of the things that we have developed is our Omni 3D high definition system. which gives same view to the entire surgical team. And not only that, this has an added benefit of to be able to tele-mentor people. So one of the biggest thing in terms of the learning curve is availability of the proctors or mentors. And so this technology will allow us to long distance mentor people, whereby we can pull the 3D images into, let's say a studio, and expert surgeon can guide other surgeons sitting literally wherever in the world. And I think the upcoming 5G technology and the fiber optic network will really facilitate all of these things, including telesurgery in future. We are also developing these smart glasses, the augmented reality glasses. So this will get rid of monitor, and it's work in progress. But I think the way we are looking at, we must utilize the technology to make it much efficient and user friendly. So some of our vision for future is to develop various different applications, including endoscopic and therapeutic applications using our single arms. And various arrhythmia treatments can be done. These arms can be used for stem cell therapy. I think also it is very important to utilize technology in terms of simulation to be able to teach surgeons and the teams so that they don't learn on the patients. So one can literally short circuit the learning curve by performing these procedures on the computer. And we hope that we can at some point develop procedure specific simulation, and that means we feed all the patient related information using various 3D imagings and so on, and perform the surgery ahead of time. So we take and make mistakes, take the guesswork out, and the surgeries will become more efficient, and they will have quality outcome because we know exactly as to what will be the outcome after we finish surgeries. Telesurgery is in the pipeline. Already experiments have been done in various countries, including us. We have used our robotic arm holding an ultrasound probe, and we control this thing 30 kilometers away, and we're able to perform the ultrasound. So I think this will become real. And as the internet speeds are constantly increasing, this will allow us to literally equip our mobile units and decentralize this care. And I think that is one of my vision, that we must decentralize, otherwise people have to travel long distances and it's very expensive in certain centers only. So there is no reason that we should not be able to give access elsewhere. And as I mentioned before, there will be further miniaturization of these technologies as the time goes on. Little message on the innovation journey. It is not easy. And I operated in Beijing, and this young lady performed after our surgery. And I looked at her, she's balancing 5 candelabras. And it reminded me of my journey that she must be absolutely committed to achieve this thing. A lot of patience, I'm sure she dropped this thing many times and persisted. So this is what really is required for people. They want to make a difference, use the ideas, commit to it, and pursue it. And finally, the reason I am into this thing in relation to the robotic surgery in this field of medicine, this is an elderly man, 82-year-old patient that I operated in Delhi, and he's a farmer from Haryana. We did 2 bypasses on him robotically, and 2 days later he went home, and a week later he was back on his farm. So really this is what is driving the innovation in relation to the robotics, because we can do same thing and get these patients back to their previous lifestyle. So thank you very much for this part, and we will get into whatever the organizers have planned, so we can get out of it. So Vipasha or Lakshmi, on to you.
Can you hear me?
Yes.
Okay, great. No, thank you so much. That was really fascinating. One of the things I love about these sessions that we do is that we feel like a kid in a candy shop. We are learning something new every time we come here. So I want to just follow up on the end, what you talked about innovations. You were talking about stem cell. research, coming into this, etc. Can you talk a little bit about it? Because on one hand, I mean, I understand you were talking about robotics, and the thing I love it is that anybody from anywhere can operate with the robot. So it's not going to be limited to the person who's there in that location. So now we can get to probably a rural area, a war-torn area, or even the space, and to be able to, do the surgery. So the advances of it, can you talk about that slide a little bit in terms of how does stem cells play a role, and where can stem cell research can take it to the next level?
Yeah, sure. Great question. And it opens up a new field that actually right now is in development. And I think most people know that the stem cell research has been going on for quite some time. And it is not easy. There are various techniques and then various regulations, because it's a very sensitive thing in the sense of ethics and how far can we take the and use the stem cells. And so one has become very, very cautious, and I think the scientists are doing, as to my knowledge, very ethically. So I think the stem cells are going to become a very important part of future medicine, because various different organs, for a variety of reasons. Take example, pancreas does not work. Okay, it does not produce insulin anymore. So one can very precisely deliver stem cells and initiate the process, or in patients who have had heart attacks and they have dead heart muscle. So there is still, the muscle does not become totally dead, part of the muscle becomes scarred, but there are still viable cells in there. So if you were to inject stem cells directly into the muscle, we can literally make them, have at least majority of their function returned back. Now, again, these are all very early on. So where the robotic arm comes into play in relation to stem cell, that because of the precision, so let's say we have 3D imaging of pancreas. Okay, we know exactly all the coordinates very clearly. And 3D imaging today, CAT scan, MRI, 3D echo, all are perfected, literally. I mean, you can pinpoint to literally millimeter accuracy today. And so one can, with the 3D imaging and based on the precision of the robotic and the software programming, one can deliver very precisely, which are hard to reach organs. One can deliver these stem cells. Same thing on the cardiac side. People have tried various ways of putting stem cells, including from inside, but then they get washed out. So again, with the robotic assistant using 3D imaging and the scans, one can go again program very precise delivery. So as we know that the robots can be controlled into a 0.1 millimeter accuracy. And so it provides that in a relatively less invasive way. Approach to give the possibility of regeneration.
Okay. One more question from your bio. Now I'm going to ask a very basic question. Is that it says that you performed the world's first single vessel beating heart TCAB. What does that actually mean? Because you have done single vessel, quadruple, I mean, you've done many. What does that actually mean, single vessel beating heart TCAB?
Yeah, so TCAB actually is an acronym. It is for totally endoscopic bypass surgery. Okay, so people are familiar with having heart attacks and undergoing bypass surgery. So right now, almost 99% of the patients will have their sternums split open. And it is easy for the surgeon, but terrible for the patient, because bone healing takes almost 4 to 6 weeks, and then people who are involved in various things. So basically, we were advancing this thing that we can literally go through these fingertip size holes and to do the bypass surgery. So the robotic assistance actually allowed us to do. And so back in the United States, I think it was in 2003 or so, I did the first ever beating heart totally endoscopic bypass surgery. I had the permission from FDA, and a cooperative patient who was willing to be the first one. Those things are not easy as a guinea pig, as they say. But we did him actually very successfully. And believe it or not, that patient, being the first one, he went home next day in 23 hours.
Wow.
And he drove himself from West Texas, where I was, to Arizona, 800 miles away in a week's time.
Wow.
And I tell you, that was very inspiring. We
Yeah.
felt that we have achieved our goal of giving patients back their life much, much faster. So basically, yeah, TCAP is totally endoscopy bypass surgery. And now, of course, as the experience grew, and as Vipasha talked about, we have done multi vessel, and I've done these things in India. Yes. And so basically, it gives the best possible options to the patients with all the possible complications that can occur with large incisions, they go away.
Yeah. So, so far we've learned about how it can be minimally invasive so you can recuperate quickly, and how we can have access to really surgeons from anywhere in the world because there is a remote surgeon operating. And we also talked about, something that you said, which is very important, is that people have a misconception of what robotic surgery is. They think robots
Yes.
taking over the world, but there is a human hand, human brain, human interaction. So it's sort of more a man-machine combination as opposed to machines taking it over. And it was really beautifully, shown in what you're doing. Now, this is all a very complicated system where everything has to work. The internet connection has to work. The connection between the surgeon and the robot has to work. The robot has to function 100%, etc., etc. What are some of the challenges of bringing such a thing to India, where we can't rely on our resources 100%? What are some of the things we need to do? So when you do it, do you always have a backup generator, or how do you make sure it can be successful in India?
So it's a great question, and I'll break it up into two parts. One is as to how do you take safety measures while we are doing things, and the other part is how do we do it in India. So maybe I think both are very, very important, and I think various initiatives that are going on, and Make in India or Atmanirbhar Bharat or this AMTC, this experiment that's going on to really bring medical technologies. I think one of the challenges that India has faced, almost 80% of sophisticated medical equipment comes from outside.
Right.
And somewhere we have lacked in investing in innovation. We have great talent in the country. Israel is a burning example. We can send, our crafts to Mars.
Right.
First attempt, okay? But somewhere, we have left behind. And I do not know whether it's the environment or the money that is required, because medical innovations are expensive.
Right.
And they require a lot of funding. There are regulatory hurdles. You need the engineering talents to put the medical ideas into engineering projects that can be useful and safe. So I think there is a great opportunity in India to really push this. And I think with the government initiative that are ongoing at this point in time, I think the program that you are conducting right now, for instance, hopefully it will create the awareness that yes, it is possible.
Right.
And so then we need funding, and it's very important to put the financial muscle behind it, because these things take longer time. It's not easy. Results are unknown. Then you still need to get through the regulatory part. Now, as far as coming to the operating room side of things, yes, since we have this as a mission statement, the first most important point is do no harm. Okay, so technologies are great, but they should do no harm to the patient. So we take every precaution, working with the engineers to make sure that it is absolutely safe. And I have this sentence that I tell my engineers: just imagine that this product is going to be used on your.
I can't hear Dr. Srivastava. Vipasha, can you hear him?
Okay, battery.
Yeah, now we
Okay.
can. Yeah. Sorry, we
Okay.
lost you.
Sorry. So let me just repeat what I just said about, so my statement to the engineers is that make it so that you can offer this thing to your mom or your dad
Correct.
or yourself. So you must do it perfectly. It's a
Yeah.
very serious responsibility,
Yes.
ethically also, that anything that touches a human medical device, it must be perfect. So
Right.
now, keeping that in mind, we have various things while designing, while testing, to take all of these precautions that we make sure that there is a reliability and you
Yeah.
can repeatedly use without causing problems. Regarding power going out and things like that, most hospitals today have backup generators, and in our case, we always have this uninterrupted power supply
Right.
UPS
Mm-hmm.
attached to the part of the machine. So
Mm-hmm.
generally, for a very brief, a minute or two, if the power goes out, these things are always there. They won't let the system go down, and generally, based on the regulation, the power kicks in. And
Right.
also, these hospitals have dedicated lines. So I
Right.
think that's a very valid point. But and one thing I think that you have pointed out, that the robot does not do anything on its own. It's a piece
Right.
of metal with software that the surgeon completely controls. It's
Correct.
an instrument in surgeon's hand. So yeah, sometimes there is a
Yeah.
fear. Yeah.
Right. And I really want to underscore the point you said in terms of innovation takes a lot of investment upfront. You
Yes.
cannot do linear investment. You have to do like a huge investment upfront and try 10 different approaches simultaneously because one of them will kick in. And this is one of the things I think has curtailed India from truly exploding on the innovation scene is the lack of upfront investment. And as you said, it's, to us, it was so wonderful meeting Dr. Sharma and seeing AMTZ to see this kind of an investment upfront. So the startups don't have to invest, but they can
Yes.
use all the equipment that is there. And this precisely what Dr. Sharma said in the first meeting is that India has a great opportunity to be a leader in manufacturing these machines. Right now, we are importing from everywhere. And I think
Yes.
that's an innovation that's waiting to happen, and we need more such upfront investments. So one of the things I also want to talk about is that as we gather more and more data, as you're saying, right now maybe we would have done 1 million, 10 million, 100 million, some numbers of surgeries, but compared to how many millions that are needed, we still are at a small numbers. So what role can artificial intelligence play in this as we get more and more data to become better at robotic surgery?
Yes, absolutely. So I think AI now is a buzzword that has
Yeah.
become literally part of life in every possible field.
Yeah.
And in medicine, particularly, designing things or data analysis or projecting what may be the potential outcome or what may be the risk, or literally calculating faster than the human brains to literally guide these machines. So I think AI will play a very, very significant role, literally
Mm-hmm.
on an ongoing basis.
Mm-hmm.
Whereby, I'll just give you an example. Let's say today patients come from different places to have ultrasound done. Okay, we can
Mm-hmm.
place an ultrasound probe and machine attached to it on a robotic arm. We
Mm-hmm.
can completely from long distance control it. Now, within this machine, we can feed all kinds of libraries of a perfect image.
Mm-hmm.
Okay, so now the machine itself will decide based on the information already in there, that every
Right.
time it is the best result and it's not dependent on technician or somebody messaging at the same time while they're holding a
Right.
probe. So I think,
Right.
so I mean, this is just a very simple example, but same thing applies in imaging, same thing applies in all kinds of new treatments that are going to
Mm-hmm.
be coming in the pipeline. I think,
Mm-hmm.
and I envision this thing in the next 20 years or so, the whole cancer treatment will change totally. Right now,
Right.
we act literally, I would say brutally, pardon the expression, but we
Correct.
make incision and we take things out. I think
Mm-hmm.
there will be a time that we will go and just destroy it locally. whereby
Right.
all kinds of, these artificial intelligence and these calculations that are done on an automated way, it will
Right.
occur. Even
Yeah.
parts of surgical procedures will become automated. And this is where, when we talk of simulation, for instance, we can feed the information. I can
Right.
operate, my movements are all recorded. And
Yeah.
of course, within the safety of parts of the procedure, machine can carry that out. Yeah,
Right.
so AI will, constantly play in data analysis.
Yeah.
I mean, yeah,
Yeah.
absolutely.
So
Yes,
I have before we open it up to everybody, I have a personal question for you.
sure.
I mean, this is really what you're doing is at the bleeding edge of innovation. And you have done this in Texas. I mean, you've been doing this for a while. Was there, in your childhood or in your school, in your college, I mean, what was the inspiration for you to do? And then you decided to come back to India from US and do this. Where was the inspiration for you to push the envelope in medicine?
I think inspiration as a physician, there's always this hunger. How can we do better?
Mm-hmm.
So that was maybe my part of my personality. And in one word, I would say maybe that was my destiny to keep pushing. A lot of people, because just accepted medicine as a way to earn a living and enjoy life.
Mm-hmm.
But then, so the desire as you are learning.
But that's just hold on a minute. But that's not you. So you are not just okay with status quo. So something somewhere
Yes.
has inspired you to say do more. Maybe it's a patient you saved and their life
Yes.
changed. And
Yes.
whatever it is, what is your aha moment where you said, my life is going to be about continuously innovating. It's not about status quo.
Sure. Yeah. So, the innovation journey started in Texas. And then I was always passionate. We trained a lot of people from around the world. I traveled, launched programs. I saw them fail because affordability factor was a major thing. So when I came to
Mm,
India at the invitation, I was really passionate. I wanted to really come to India to bring this technology
mm,
and really contribute, because ultimately I'm grateful to the motherland. That's how I
mhm.
became a doctor.
Right. Yeah.
A lot of people gave me a lot of things in my early days. So it's
Hmm.
time to return back. So I came with the idea to launch robotic programs. And I'll tell you this very brief story. I think it's probably worth listening as
Yeah.
to what changed my direction from a
Yeah.
surgeon to get onto the innovation pathway.
Mm,
So there was a
mm,
22-year-old female who had atrial septal defect, and that's a hole in the heart between two chambers.
mm,
Now, in India, culturally, if she has a long scar in front, unmarried woman, very difficult to get married. And her
mm,
brother brought to us, they didn't have money,
mm,
and we could do it robotically. I said, we'll do it free. Hospital didn't want to give them free care. And so the brother said, sir, give me some time. We'll try to raise money and come back to you. A month later, he called me. They're still struggling and trying to find. I never heard from him. And I tell you, that hit me.
mhm.
That
Yeah.
this technology and technique that would have saved her misery and
Mm,
her future, we could not do because of money. So I
mm,
made it my mission to come up with a system that will be affordable.
mm,
So that became literally, so I used up all my personal resources, went bankrupt, borrowed money, sold my car, sold my furniture,
mm.
support the team while looking for money.
Right.
Okay,
Yeah.
because these things, they're tough. And so
Correct.
finally we lucked out. And so, but there was really, the idea was that there's only way to change if it is expensive. Yeah, surely some people will get it done because they have the
Correct.
resources. But healthcare, it is a right. And it's a
Correct.
right for the best possible care for everyone.
Mm-hmm.
And that
Mm-hmm.
really has been, the humanitarian side of the vision. Yes, there is a business model, and
Yeah.
that's a secondary thing as far as I'm concerned. Don't
Mm-hmm.
tell my investors that, but but really,
They know
that
it
is.
already, let me tell you.
But that is really that is what is driving that
Correct.
we
Correct.
must change. Yes.
I really thank you so much for sharing that because I wanted to bring forward, because every time we talk to someone, there is something that drives them, and sometimes it's a building on success, and sometimes it's failure, and your inability to support someone became your purpose, and drives you, because I'm sure you think of that woman always. It stays in your, I mean, after so many years you're still talking about it, so that means it had a profound impact on you. And I would like to, we have a lot of young people from AMTZ from around the world watching this. And I think the important lesson out of this is to not to be disheartened by what doesn't happen, but take that as a challenge and make sure it doesn't happen again. Otherwise, we might say, forget it, nothing happens, and resign, or wait for, there should be some government funding or something like that. But here you went about doing it yourself. With that, we have 15 minutes. I want to take some questions from the audience. And when you get a chance, just explain to us what's behind you. So
Okay, certainly.
so it's a beautiful robotic arm you have behind you. So please let me know. Rohan, are there any questions online?
Yes, Lakshmi, I've sent it to you. Do you want me to read it
why
out?
don't you go ahead? Why don't you ask a question? Then meanwhile, in the AMTZ location, if anyone wants to ask a question, they can come to the mic. If you can put the camera on the mic, we'll know if people are lining up in front of the mic and we can have them ask questions. Meanwhile, why don't you ask what came online, Rohan?
Sure. Dr. Sudhir, the first question coming in is from Vishwa, and he asks, how will surgeons in India have the opportunity to learn and implement robotic surgical techniques in the future?
So, like any other robotic program, there is a very strict training protocol and a pathway. And so people go through formal training on the system, and then they practice hands-on, and then of course, we provide assistance in terms of proctorship. And one of the things that we have, at least, and we hope to really implement, the plan is to create what I call Omni Studio. So the system of 3D, we've named it Omni. And so we can utilize this thing literally to guide surgeons sitting wherever, because there's one of the challenges. When I was in US, I will get calls from the companies, come and proctor this and that and so on. And it's just not possible. It's very unpredictable. Schedules change, expensive. And then if you're doing your primary surgeries and so on, you can't just be all over the places. So, the technology, I think, will help us to help launch these programs. And also as we develop telesurgery. So technology, the telementoring will be like having somebody standing in the room watching you and guide you. We can do the same thing with the video feeds today. Secondly, telesurgery will allow literally having your attending surgeon across you who is training you. And when you cannot do something, they take over and finish it. So I think this will create a tremendous comfort zone for the surgeons. And I think, I've talked to many surgeons, they're very hungry to learn new things. I mean, that's a desire of a lot of young surgeons. So, and not just young surgeons, the old surgeons like me too.
Right. Yeah. No, I think it's really inspiring. Is there any question from the audience in AMTZ auditorium? Is there anyone who wants to up and ask a question?
Coming up, Lakshmi.
Pardon?
There's somebody walking close to the mic. Hi.
Okay. Somehow I'm not able to see it.
Good evening, I'm Dr. Kavita. I just want to ask one question. There are psychological barriers associated with robotics. Like if I'm a patient and a doctor prescribes a robotic surgery, so there are so many things I'll think whether this will be successful or a robot will, do a surgery. How will it happen? There are so many psychological barriers associated with this technology. So how to counsel a patient, or were there any challenges on this account when such surgeries were performed previously or they are being performed today? So I just wanted to know this.
Yeah, no, that's a great question. And when
Thank you.
practicing actively, we face this all the time. And fortunately now with the internet age, it's amazing. And the children of parents or so on they have already done the research by the time they come to us. And they have a pile of papers with them in their folder and a list of questions. And so what we did, proactively, we created an education program. We created teaching brochures, DVDs, and people who will sit down and literally get the family together, show them their surgical video. I used to do that in my office in Texas. I had a conference room, I had a large screen TV, and we'll play it for them. So this is exactly what we do. So one of the biggest thing was always, what if it fails, robot fails? Or what if robot goes crazy? So we literally had to drill this in, that I am still operating. If I don't move my hands, nothing moves. So it required, a learning process. And ultimately, I think, patients one must recognize they are anxious. There is so much unknown. What will happen? So I think one of the things that we did, we will monitor our own results, not what's published in the journal or what somebody else has done in some other center. So these are our results. This is what we did. These are our outcomes. So it becomes a tremendous, comfort level for them that, yes, I have come to this surgeon. Okay. And yes, there is always a risk, unfortunately, in medicine, but it is something that the benefits way outweigh the risk. So yes, we had a very organized program. Actually, we created websites to teach people. So we had a section for patients, whereby patient testimony, all kinds of things were posted.
And also sometimes you can use popular entertainment to talk about it, because I remember Shonda Rhimes talking about inserting this in Grey's Anatomy. So the surgical, Miranda Bailey actually learns robotic surgery, and all the frustrations and what the patients say. And she says it's not that easy to do, and what training she has to go through to learn it. And sometimes you can insert these kind of things in popular fiction also. So, people start talking about it and seeing it and feeling it. It's one of regular stuff,
Yes.
And Rohan, is there a question online?
Thank you so much.
Thank you. Thank you.
Thank you, Dr. Sudhir. We have another question coming from online. This comes from Nitin, and he asks, how do you succeed in developing a complex medical robotic system as a startup?
Boy, that's a loaded
So
question.
meanwhile, anybody else from AMTZ auditorium wants to walk up to the mic, please start walking up so we know you're interested. Sorry, go ahead, Dr. Srivastava.
Yeah, that's a loaded question. It's like, it's a very complex system. And one thing I learned doing heart surgery, we will get all kinds of very complex problems. And we break it up literally into various segments. And this is how my mind became when we took up the robotic project. If you look from here, my God, so many components and everything must work together, software and what if and what if. So basically you break it up into these things, and each is looked at independently. So I think also it is very, very important because in the medical world, it's a great combination that is required of the clinical knowledge or experience and engineering talents. Because sometimes, engineers will make things thinking that it will work, and it doesn't when it is given to the surgeon. So I think, one thing that we moved fairly quickly in this field, mainly because of my literally morning till night involvement with the engineers and constant discussion and brainstorming. And so you literally compartmentalize the issues and you solve, and suddenly problems are solved. So that is one way that I approached. Of course, I'm aware of companies that have they spent $300 million and the robots are still not there after 7-8 years, including giants like Medtronic and Google and J&J and so on. But I think, what I see, in some of these things lack is this marriage between the clinical team and the engineering team. Very, very crucial. Because
I just want to, I just want to say, sir, doctor, you showed that dancer show, 5 things, right? So when I think of you, I think of, on one hand, you are an entrepreneurial candelabra. On the other hand, you have a science, then you have research, then you have engineering, and at the end it's the consumer, how to explain, educate the consumer, and you have to do all 5 things at the same time. It's not like you wait till the robot is ready and then you talk to the consumers. You have to do everything simultaneously.
There's a lot of parallel tracks.
Yeah. And I think, it's a great question, and I want to acknowledge the answer to say the reason why the innovation coming from India could really be global is because we understand how to make the most with the least. That doesn't mean we should do it with the least. We should have enough to be able to expand, because we are used to not wasting our resources. And I think, Dr. Srivastava, that's where years of experience of you combined with the young force that you have at the company is a great combination to create what we need out
And
there.
I think sometimes being poor expedites things.
Yes. But having said that, we've used this argument many times before, where people say that and say, here is the least amount of money, do something with it. And I always say, no, don't do that. Give them enough to be comfortable, not enough to be extravagant, but enough to be comfortable. In India, we have the other problem of we don't spend enough. So I think we have to learn to spend more on innovation.
And one thing, if I may take this liberty, it's like, I would love for more people to materialize their ideas, but do it in a very calculated and stage by stage, because these things cost over $200 million to literally take a product to the consumers at a massive level. Okay, but we always start small. We started with $5 million. We got the funding, but then the way I looked at it, at this stage, I can do so much. So I reach a milestone. With that, I raise more money.
Right.
And then with that, I hire higher level talents. And so on. And each stage we must plan ahead of time. But we must be very diligent, because most companies, startups fail because they run out of money. And so one should not take on too many things at one time. Start out small, have a goal, raise more and more.
Yeah.
Okay.
So we have time for one last question. It's 12:20. It's 3 more minutes to go. So please
show the system.
Let me know if you have any questions.
Sure. I think we have time for one more question. I'll go ahead and ask that. Dr. Srivastava, the question is, how do you see SSI product and approach would help to accelerate medical device development in India? And what are your suggestions for the Indian medical industry?
I think if you could serve as an example, that a group of people who are committed, they must have a vision to make a difference. Very, very important. It cannot be casual. It cannot be a job, 9 to 5. And our team works that way, literally. I mean, I won't get into it, because tomorrow will ask for holidays. But it is really, the commitment. Hopefully, we can inspire others. That if you have ideas, don't give up. That's the most important thing, is don't give up. And I think the way I see, any good idea ultimately will get the funding. Yeah. So, when you talk of India, because we have lagged behind in, putting money upfront in innovation, because of long gestation periods and uncertainties. But if you don't do it, and I think there should be really a government and innovator partnership. I know, I think funds have been created. I think it is time that we put them to use, actually. Figure out a way to make these things available, have committees who can screen the ideas, look at what do we need in the country to be, Atmanirbhar. We must do that, because otherwise we'll keep talking, and year after year will go by, and the same story will be. So somewhere we got to say, it is not then, but it is now.
Right.
I think that should be the approach.
And, really, I want to wrap up by saying, Dr. Srivastava, last week we did a conference all on AI, AI in health, AI various things. And it was started by Nivruti Rai, who's the head of Intel in India. And she did a fantastic quote by Dhirubhai Ambani. What it says is that it's important to dream big, but you have a choice of either you pursue your dream or you service somebody else's dreams, you know. And for the last 20 years, we have 25 years, we built an amazing technology industry in India that was serving somebody else's dreams.
Yes.
So it's time we moved forward to pursue our dreams because the world is waiting to contribute to it. Because today, I'm right now in Europe. In a minute, I'll show you. I'm in the middle of a farm in the middle of nowhere right now. And around the world, wherever I talk to people, they want to be part of the India dream. They want to make a difference to a billion people. But unless we have a dream and say, this is what I'm doing, nobody will come to work with us. We can't do this alone. I mean, we need the best minds from around the world to come together. So it's very inspiring, Dr. Srivastava, to see how you and Dr. Sharma, all of you at AMTZ, all the many companies that are there, are focusing on creating a national dream for us and bring the best minds from all over the world, people like you coming back from different parts of the world to make it happen. And this is why we are excited about this TechRx series. This is every month we'll be featuring a conversation like this. So please be part of it, share this with your friends, and make sure everybody knows what it takes to make it happen. And I want to summarize, Dr. Srivastava, to say that it's not enough to have a dream. You need to have the experience, the diversity, because in your company you have engineers, you have web designers, you have the doctors, you have all sorts of people, to have the diversity of thought, diversity of gender, diversity of age, diversity of experience, to make it happen. So really want to congratulate you and thank AMTZ for making this series possible to do this with us. And we'll be back again next month. Please watch out for our social media for this. So
thank you, Lakshmi.
thank you.
I mean, it's been wonderful. And
Thank
if
you.
I can say one sentence to
Sure.
appreciate my great team in India, in China, literally all over the world, we have highly talented people because I could not do it alone. And
Yes.
our investors, we've raised a lot of money, and I want to really thank because for their trust, actually, they put,
Yes.
so we can bring something that
Yeah.
will help people in a very different way. And thank you for this opportunity. Yes.
Sure. And just everyone remember this visual that you have of the robot in the background, but a human at the center. That's the future of robotic surgery. It's not machines taking over. It's the brain of a human being and the robotic arms working together. So it's a beautiful visual. Thank you so much for doing this out of your lab, Dr. Srivastava.
Thank you.
Thank you,
Jai Hind.
everybody.
Namaste.
We'll be back next month. Bye-bye.
Bye-bye.